got left here and do a little bit of equation solving with you guys. This is going to be more the paper pencil stuff. And then we will quick finish up with some of the calculator work in solving equations if we got some time to do that, which I think we probably will. I can get through this pretty quick. So, need to talk about something called the zero product property, which is something you've seen before, but maybe don't remember it. It goes like this. If I multiply two numbers together, and I'm going to call them just A and B. So if A times B equals 0, then that means that one of those two numbers you multiplied together had to be 0. Does that make sense? The only way to get 0 as an answer to a multiplication problem is if one of the two numbers you started with was 0. So this is kind of the basis for how you used factoring to help solve equations. So as an example, if you were trying to solve the equation x squared plus 5x plus 6 equals 0, you can't do it directly, right? But if I factor x squared plus 5x plus 6, then I turn it into a product. Then I turn it into a multiplication problem instead of an addition problem. And then I can use this property to help me solve it. Okay? So, do a little quick factoring review here. We'll do a lot more of this in Chapter 2, but for right now, you guys remember the trick with the trinomials? How you can figure out what the two numbers are you need to factor it? What am I going to need for this one? X plus 2 and x plus 3. Right. What two numbers add to 5, but at the same time multiply to 6? Okay. And now I can use that zero product property to solve it. So since I'm multiplying these two things together, I know that either x plus 2, the first factor, equals 0, or the second factor, x plus 3, equals 0. So what are my two solutions here then? So if x plus 2 equals 0, what's x? Negative 2. And if x plus 3 equals 0, what's x? Negative 3. Good. Okay, so sometimes the trick is going to be just getting it into a multiplication problem. Sometimes it's already going to be a multiplication problem for you. Okay? Like, for example, and it might look a little bit more complicated. Like that. The idea is still the same. Okay? You're still going to use the zero product property to break this thing up into two little problems that you can solve then. Okay? So the first one, 3x plus 2 equals 0. Just a quick couple steps and you're done. What's the solution to that one? Negative 2/3, right? All right, what about this other one? Square root of x minus 1. How do you solve something like that? You can square both sides. Remember, it's algebra. You can do whatever you want to either side as long as it stays the same. So if I square both sides, 0 squared is still just 0. So it's x minus 1 equals 0. And then what's x for that one? 1. Now, the only thing is, with ones like this, if it's got square roots in it and that sort of thing, you do have to double check to see, are there any extraneous solutions? Do you guys remember what that is? What's an extraneous solution? Yeah.
So shouldn't square if you plug in x to one spot, it'll come out to 0?
Not to 0, but it'll come out undefined. It'll be something you can't have, right? So let's double check that, okay? Negative 2/3, okay? I should be able to plug negative 2/3 into both places for x and have it work. Okay? So if I plug negative 2/3 in here, I'm good, because this becomes 0, right? What about if I plug it in here? What do I end up with there? You get a square root of a negative number, which is undefined. You can't do it. So this is extraneous. So technically that's not a solution. What about 1? Can I plug a 1 in both places and end up okay still? Plug it in the first one, I get 3 times 1 plus 2, that's 5. Okay, plug it in the other one, I get square root of 1 minus 1, that's 0. 5 times 0, that's 0. Yeah, the 1's okay. That one we can plug in both places. But that negative 2/3 became a problem with the second x, though. Yeah?
You only have to worry about it with the square root?
In this case, yeah. And we'll talk a little bit more about that later in this class when we talk about domain. But, yeah, because looking for extraneous solutions is only going to be, if I plug it in, does it give me something that is undefined? And nothing in 3x plus 2 is going to make it undefined. The square root, yeah, there's going to be some problems there. So really, you're just going to be looking in that one. But so x equals 1 would be your only solution for that one. Okay, so that's using the 0 problem through it, through solving some of those kind of equations. So using the calculator, sometimes you're going to have some equations that you can't factor or you can't solve by hand. And you can use your calculator to help you get through it. So let's say I have the equation I want to solve is something like that. 5x squared plus 3x to the third minus 10 equals 0. Can't factor it, okay? Even with all of our complex factoring techniques that we're going to talk about later on in the class, we wouldn't be able to do it. Can't factor it. So we can graph this equation on the calculator to get to a solution, though. Okay? So what we got to be careful of, though, is when we use our calculator to graph equations, and we've been using it to graph scatter plots, it don't like the two things at the same time. Okay? So you have to turn off the stat plot if you want to do this. Okay? And if you're going to do a stat plot, you have to clear all of these out at the same time. Okay? So you got to get rid of one or the other. You don't have to get rid of the data in there. You're not going to lose all the data that we typed in. But you just have to turn it off. Okay? So here's the other one I was working with. So with mine, if I go into y equals, notice how the plot 1 and 2 are both highlighted. Here's one way you can turn them off. Just right in the y equals menu, go up and hit enter, and that'll turn them off. You can do it that way. Let's say these were still turned on. If you go into stat plot right here, then you can go in and manually turn them off. But then you got to go through this twice and go to each one and turn it off. And it takes a little while, but it can be done. And then you go into y equals and you're ready to roll. Okay? That's what's needed for. Okay? So, I'm going to use a different calculator for this because that one's being a little weird. Okay, so this equation that we're going to look at. Okay. Plus 3x to the third minus 10. We're going to type that in. Okay. We want to know when this is equal to 0. What about the graph is going to tell us when this equation is equal to 0? Yeah. You got it. Exactly. When it crosses the axis. So we're looking for x-intercepts on this. Okay. So it now might be such that we can't see anything, but we can take a look. This is the window that we had, or at least this is the window that I had from before when I used this calculator last. You guys from your stat plots might be something different. Okay? By the way, you should notice it is appearing to cross very near 1, right? Oh, actually, your window, you wouldn't be able to see that, right? Because you started at 55. So let's switch up the window again. So your x min and max, if you don't know at all what the thing's going to look like, this is a good home base for functions when you're typing them in. X min at -10, x max at 10, same thing for the y min and the max. Just make sure you're using the negative button and not the minus button when you type those in, otherwise it's going to yell at you. But that's what's called the standard window. Okay, so if we start at a standard window, hit graph again. Okay, we can see that function. Okay, does its quick little turnaround down there, and then it shoots through here. It appears as though the solution to this is 1, but if you plug a 1 into this real quick, you're going to see it's not exactly 1, because 5 times 1 squared is 5, plus 3 times 1 cubed is 3, so 5 plus 3 is 8. 8 minus 10 is actually -2. Okay, so we got to pinpoint that a little bit better. Okay, so first thing you can do, since we know the solution is really close to 1, we can go back and change our window again and make it smaller so we can see it better. So like -2 to 2, -2 to 2 maybe instead, and just look at that. And that'll give you a much clearer picture, and you can see it's like slightly bigger than 1. Okay? So how do we get to exactly where that is? Well, if you go second, and then up here it says calc. So second, calc, we're looking for a 0. So then you go down to 0, hit enter. Just let me know if I'm going too fast here, guys, because this is a lot all at the same time. Okay, and it's going to ask for a left bound and a right bound. So this left bound, there's going to be this little cursor that's like blinking on the function, and you can move it left and right. And you might not be able to see it right away, but if you keep moving it to the right, eventually, as you get closer to 1 for x, you should be able to start seeing it moving up the line there, or up the curve. Okay, so left bound means we want to go just slightly to the left of where we think the 0 is. Okay, so just slightly to the left of it would be like down here then. Okay, so hit enter. And then the right bound, we're going to go just a little to the right of where we think it is, maybe like up there somewhere. Hit enter, and then enter one more time, and now it's going to pinpoint where it's at, which is about 1.098 is the solution. Okay, so if I solve this equation, my solution would be x equals 1.098. Okay, I know there was a lot there. Okay, but that process is you graph the function, go to second calc, go to 0, do the left bound, the right bound, enter one more time. Okay, it's on the video that you guys can go get later too. You can watch me do it again if you need to. Okay, but that's the idea. Now the only other thing that might happen is, what if you use the calculator to solve an equation, but it's not equal to 0? So let's say it's like, I don't know, 6x squared minus the square root of x equals x plus 2 or something. Okay? Well, there's a real simple first step you can take with something like that. If it's not equal to 0, make it equal to 0. How do we make it equal to 0? Move everything off the other side. Okay? So, if I was going to do that, I'd have 6x squared minus the square root of x. Subtract the x to the other side. Subtract the 2 to the other side. And now I can type that into my calculator. I'm not going to do it, but if you were working on something like this, you could type that into your calculator and then go look for a solution just like we did the last one. Okay? So that's the idea. All right, and I am all done. So I'm going to get you guys your assignment here in just a second.